Okay, quad Q1 test. So what is the negative solution to 2x squared minus 6 equals x solved by factoring? So we know when we're solving by factoring, first things first, it has to equal 0. So I know because 0 equals ax squared plus bx plus c is the form I want it in. Okay, so I have to get a, b, and c on the same side. I know a has x squared, B has x, and C has nothing. So I need that x to go in the middle on the left. So how do I move a positive x? Minus x minus x. So I get 2x squared minus x minus 6 equals 0. Well, I know I could put a 1 here, and my GCF can never be bigger than my smallest number, so I don't have a GCF other than 1, so I don't have to divide anything out. And it says by factoring, so I have to do the box. So I'm going to identify my A, B, C. A is 2. B is -1, and C is -6. Okay, I'm going to build my table, and I'm going to build my box. So I know A times C goes here, which is -12. B goes here. And I need to figure out what multiplies to give me -12, but adds to give me -1. So that's where my calculator comes into play. I'm going to type my A times C, which is -12, divide X, and I'm going to hit the settings table. And then remember that third column, we want this column plus this column to equal -1. So we want X plus -12 divide X, and we're looking for -1. So I'm going to type 3, and there it is. So +3, -4. So I know that I have a +3 and a -4 for my two special numbers, which go here. They always have an x behind them. And then remember, first term, first box, last term, last box. And now we GCF everything. Now I'm going to just look at letters first. These both have an x. This one has 1, this one has 2, so we take out 1. Remember, we always take out an x here and here. And we never do here because your C term doesn't have an x. Okay, C term doesn't have an x, not here. And then remember, if this is minus, this is minus. If this is plus, this is plus. And now we just GCF it. My GCF between 2 and 3 is 1. My GCF between 4 and 6 is 2. And again, remember, you can use your calculator. So you can type GCF 4, 6, and it's going to tell me 2, which is why I know 2 is here. And again, I could do that here, but I know my GCF is 2, 3 goes into 6, so it's 3, and there is my factors. Now I'm not done. Those are just my factors, so I have a factor of x minus 2 and 2x plus 3. I could check my work by typing this in my first line, this in my second line, and making sure they match. And then I have to separate and solve. So x minus 2 equals 0. 2x plus 3 equals 0. Add 2, x equals 2. And remember, we're solving for x. You have to get rid of addition first, and I get 2x equals -3. Divide by 2, and I get -3 over 2. So my solutions are -3 over 2, comma, +2. However, it's asking me what is the negative solution. Well, 2 is positive. Positive solutions are not negative. I don't have a -2, so A is my answer. So that's probably the one with one out of the two with the most work. Okay, look at number 2. This is a square root problem. And I want you to realize what's squared. We have to get whatever is squared alone first. So right away, I see that this is already alone on the left side of the equal sign. So I'm going to go ahead and square root both sides, because that's my second step. On the left, remember, square root cancels squared. I'm left with x minus 2 equals, anytime I take the square root of a number, I get a positive and a negative. And then remember, we are checking it in our calculator every single time. So check mark 49, and it equals 7. So I don't have to do the factor tree because it gave me a whole number. So knowing that, I need to add 2 to both sides. I get x equals 2 plus or minus 7. And now I realize these are both whole numbers, so they are like terms. So I'm going to separate, and I have 2 plus 7, 2 minus 7, and I get 9 and -5. So my answer is D. Okay, number 3 has us just simplifying a radical. So remember, we're going to do our factor tree. Now, to remind y'all, prime numbers, we want our ends of our tree to be prime only. So 2, 3, 5, 7, 11, 13, I always forget that one, 17, so on and so forth. And I personally always like to start with my smallest prime number, which is 2. 2 does go into 48, and if I'm not sure, I can divide. So I know 48 divided 2 is 24. So I know 2 and 24, so on and so forth. I know 2 goes into 24 12 times, 2 goes into 12 6 times, and then 2 goes into 6 3 times, and 3 is prime, so I'm done. And remember, we circle our pairs. So I have a pair of 2's, and a leftover 3. So I'm going to take a 2 out because of this. Remember, because I can rewrite this as 2 squared, and a square root cancels a squared. So I only take 1 2 out because of the circle. I'm going to take another 2 out because of that circle. And remember, it's factoring, so we're multiplying. And then my 3, my leftovers have to go back inside because there was no pair to take it out. Well, 2 times 2 is 4, square root of 3. And here it's just saying what square root of what. So your A is what's in front, and your B is what's in second. So 4 is in front, 3 is second. Okay, let's look at number 4, goodness, skipping ahead. Okay, this is another one just like number 2. Okay, so this is saying to leave it in this this form. So I'm going to rewrite it. X equals A plus or minus B square root of whatever that is my C. That's how I rewrite it. Okay, so knowing that, remember, first things first with these methods, you have to make sure whatever's squared is alone. And on this problem, it is alone. So then I can go ahead and square root both sides. So square root cancels the squared, and I get x plus 3 equals positive and negative something. So always, always, always check it first. So check 8. And it gives me this ugly decimal, can't turn it into a fraction, nothing. So I have to factor tree it. So I know 2 goes into 8 4 times. 2 goes into 2 2 times. 2 is prime, so we're done. I have a pair of 2 and a leftover 2. So this is going to become 2 square root 2. 2, 2. So knowing that, I have to get x by itself. So I'm going to do minus 3, minus 3. I get x equals negative 3 plus or minus 2 root 2. Now, the reason we're done and we cannot go any further is because, remember, square roots or symbols or radicals or whatever you want to call them are like letters, and they have to be exactly the same to combine their coefficient in front. So I have a negative 3 plus or minus 2 root 2. It's a 2, I promise. Okay, let's look at number 5. Number 5 is a calculator problem. It says, what are the x-intercepts of the graph? Okay, so knowing that, I'm going to type it in my calculator. And I know I'm typing y equals 4x squared plus 2x minus 6. And I'm looking for my y-intercepts. So I'm going to slide that over. And I'm looking, I have one here and here. So I have negative 1.5 and 1. So I have negative 1.5 comma 0 and 1 comma 0. So knowing that alone, I know that I have to have a 1 comma 0, which this one does. This one does. This has a negative 1, not the same, and this one doesn't have it at all. So I'm between B and D. Well, I know negative 1.5 is not 2, so I know that's not my answer, but let's double check this. So I can type my negative 1.5 and turn it into a fraction, and it is negative 3 over 2. So this is the same thing as saying negative 3 over 2 comma 0, which is what this has. So B is my answer. Okay, let's look at number 6. Number 6 says, which of the following quadratic equations has exactly one solution, and that solution is positive? So what I'm saying is we want a graph that only touches the x-axis one time. So that means the vertex is on, and we want it to be on the right side of the origin so that way it's a positive number. If it was on this side, that would be a negative number. So let's type these in the calculator. It's another calculator problem. So I know x squared, minus 10x plus 25. And I'm going to zoom in. This does touch at a positive 5 only one time. So I see that this could be my answer. Let's double check some of the other ones just to be safe. So plus, this touches at a negative, so that's not it. That's a negative single solution. X squared minus 10x. That has a 0 and a 10. That has two solutions. Remember, we only want one. And then if I check minus 25, again, I still have two solutions, a positive and a negative. So these are not my answer. A is my answer. Okay, let's the next page. Okay, number 7 is a simple one. Don't let this one be hard. It says a table of values for the quadratic function f is shown below. So we know this is a U-shaped, a quadratic. If 2 is one of the solutions of the equations, when f of x equals 6. So I want you to realize that's here. 2 is my solution when y equals 6, when f of x equals 6. It says, what is the value of the second solution? Well, the best part about quadratics is the table builds the rainbow. So we have negative 6, negative 4, 0. Therefore, if this is 6, whatever comes on the other side of that 0 is also 6. Well, if I follow 0, negative 1, negative 2, negative 3, negative 4, negative 5. So that is my other solution where x is negative 5. Okay. And the reason, oh, just kidding, don't listen to me. Okay, this one, number 8, says Madison found the zeros of a graph to be a half and negative 3. What are the factors? Like two answers. So I want you to remember that if I know these are my zeros, I know it's saying x equals 1/2 and x equals negative 3. And factors are when this whole thing equals 0. So I need to move my numbers back to the x side. So I'm going to add 3, and I get x plus 3 equals 0, which remember, we had those factors that equal 0. So I know x plus 3 is one of them. And then my other one, well, this is a fraction, and we have to get rid of the denominator before we subtract. So we've never had a fraction and a factor. None of my options have a fraction. So remember, divide by 2. That's what this fraction means, divide by 2. So the opposite of dividing by 2 is multiplying by 2. And now I have 2x equals 1. Minus 1, and I get 2x minus 1 equals 0. So there's my other factor. And I can also check my work because in factored form, this is saying f of x, or whatever you want to call it, is 2x minus 1, x plus 3. So let's check that in our calculator. I'm just going to write y equals 2x, goodness gracious, minus 1, x plus 3. And I'm going to make sure it touches at negative 1.5, or negative 3, sorry, negative 3, and positive 1/2, and it does. So we did it correctly. Okay, let's look at number 9. It says, which statement about f of x equals this is true, and it gives me options. So we're going to go ahead and just type it in our calculator. So I know f of x equals 3x squared plus 4x minus 15. So I have this, and I want you to realize I have a solution at negative 3 and 1.6 repeating. So I could do 1.6 repeating. See how the fraction thing disappears? When it pops back up, I can click it again, and it's 5/3. So I have x equals 5/3 and x equals negative 3. Well, negative 3 5/3, negative 3 5/3, these have the opposite, so those are wrong. However, I still have two answers. So now it's kind of wanting me to go forwards or backwards again on these. So we can also just type it in our calculator. So I'm going to come over here, and I'm just going to type B in the calculator. And then, I capitalized it on accident. So we're going to look at it. Why does it keep capitalizing it? Caps lock might be the problem. And if we look, these do not match. Therefore, those are not the same. Therefore, D has to be my answer. And I can even quick check. This was just minus, and this is just plus. And it's exactly the same. So I know that that is correct. Okay, let's look at the next page. Okay, the function f of x equals x squared minus 8x plus 7 is graphed for us. And then it says to do that when it equals -5. So what I want you to realize is this is like when we would type the left side in y1, or the first line, and this in the second line. Well, if we don't remember what y equals -5 looks like, good thing we have a calculator. Y equals -5. So it's a horizontal line at -5. So at -5, I'm going to draw a horizontal line. Or just looking where they touch. So they touch at 2 and 6. So 2 and 6 are my answer. Okay. Solve the quadratic equation. So again, it's a square root problem. And I know that I have x squared. So I need to get x squared alone. So I have to get rid of the 16. So I'm going to divide both sides by 16. And I get x squared equals, I'm going to make sure it doesn't simplify. So I get 196 divided by 16. And it does not. Oh, it does. 49 over 4. Just kidding. Don't listen to me. 49 over 4. And now I'm going to square root both sides because what's squared is alone. So square root cancels the squared on the left, and I get x equals positive and negative something. Well, this is where my calculator becomes my friend. We're going to check it. So check 49 over 4. And I get 3.5, which is 7 over 2. So my answer is 7 over 2. What did I do wrong? 196. That's what I did wrong. No, 196 over 16 gives me 49 over 4. What am I doing? Let's type it all together. It's the same thing. Oh, goodness gracious. I'm a mess. It's 169. There we go. I was like, what am I doing wrong? This is I switch numbers all the time. It doesn't simplify. Goodness. Sorry, y'all. So I get x squared equals, I'm going to redo it over here. 190. Dang it, I'm doing it again. X squared equals 169 over 16. Does not simplify. Now that this is alone, we square root both sides. Squared to squared. Positive and negative. And if I type it in my calculator, which I did here, it's 13 over 4. I was like really baffled for a second. Okay, so I have a positive and negative 13 over 4, which is right here, which is D. Sorry about that, y'all. See, teachers make mistakes too. That's all I wanted to show y'all. I did that on purpose. Okay, 12 says solve the equation by factoring. So this is a lot like number 1. However, it's already equal to 0, which is great. However, we still need to check for a GCF first. So if we struggle checking for GCFs on our own, I can type GCF and I can type my numbers. So I have a 3, comma, -12, comma, 12, and I get a GCF of 3. So I'm going to divide that out. So divide by 3, divide by 3. My account needs attention. Divide by 3, whatever that means. Okay, so that leaves me with x squared minus 4x plus 4 equals 0. And again, it's already equal to 0, which is great. So now we're going to go ahead and check for our A, B, and C. 1, -4, and 4. And I'm going to write my 3 down here like we're supposed to. Build my table. Build my box. A times C, B. I'm looking for what multiplies to give me that and adds to give me that. So B is -4. A times C is 4. And so it's going to be -2, -2. First term, first box. Last term, last box. And remember, we always have an x here, here, minus, minus. So x, there's no GCF other than 1. Here I have a GCF of -2, 1, -2. I see they match. So this is just like writing x minus 2 twice. Well, remember, when my GCF is just a number, if I were to set that equal to 0, it doesn't change anything. You can't solve, so we can ignore our GCF. and I'm going to set my two factors equal to 0, and I want you to realize they're the exact same thing. So if I add 2, I'm going to have to do that here as well. And I get x equals 2, x equals 2. Well, they can't touch twice at the same spot, so what that means is it's only 2. Again, you could also check your work in the calculator by typing what was given to you. Now, this is a show work problem, so you still have to show me all your work, but I could type 3x squared minus 12x plus 12, and I see that it touches only at positive 2, so that is correct. Okay. Number 13 says, on the top it says the graph of the function f x squared minus 16 is shown below. Which statements are true? So it says the function f has no real zeros. Remember, zeros equal x-intercepts. So I do have 2 x-intercepts, so that's false. It says the solution set of the equation x squared minus 16 equals 9. Well, remember, that's like saying y equals 9, which is horizontal line at 9. And that equals negative 5, positive 5, which is true. The function f has 1, 0. We just proved it has 2. 1, 2. So that's not my answer. The function f has 2 zeros at negative 4 and 4. So there's negative 4 and 4, which is true. And the solution set is negative 2 and 2. When it equals 0, that's your x-intercept. It's not negative 2 and 2, so that's not my answer. So B and D is your answer. Okay, let's look at 14. It says, which graph best represents this? Well, y'all, we can literally type this in our calculator. So we have g of x equals x plus 3, x minus 5. And I'm just going to look at my intercepts. I have an intercept at negative 3. And x equals 5. And I'm going to compare to my graphs. Now, 2 of them are here and 2 of them are on the next page. So this is not negative 3, so that's not my answer. This is negative 3 and positive side, so this is probably my answer. Doesn't even touch. This would be no solution. And this only touches ones at positive 3. Again, not my answer. So my answer is B. Okay, 15 says, given the inequality, which direction would you shade and what type of line? So you could solve for y, but kind of like we talked about on our warm-up the other day, I want you to realize we look at y because when we divide, we decide if we flip our symbol by our dividing by our y. Well, my y is positive, so I'm not going to flip my symbol. So this is my final symbol. Solid line underneath means solid line. So I know it's not going to be dashed, not going to be dashed. And this is the, remember, left makes less. So hold up my left hand, or even less, L-E-S-S. I did cursive, but L-E-S-S. So that says less. And if something's less than you, that's below you, which is down. Okay, let's look at 16. What would be the first step to solving this equation by factoring? Well, first things first, has to equal 0. So I would have to do minus 12 minus 12. Subtract 12 from both sides, which is D. Okay, 17, almost done now. This is a calculator problem. First off, it's asking about correlation, which is telling me scatter plot, which means I have to type all the points. So I'm going to do plus sign table. So I have 2000, 2005, 10, 15, 20. And remember, when we're typing our y's, we cannot have commas. So 97,000 is just 97000, 121,000, 5000. Okay, so we are going to click this little magnifying glass to make it zoom in perfect. There's my points. I do see that they're increasing, so which is positive. And we're going to type our y1 squiggle first. So y1 squiggle mx x1 plus b. I do realize it's positive data. It's and my r is, I'll write it down. Oop, r equals 0.8664. Okay, so knowing that I have a positive 0.8664. Well, this is a negative, this is a negative. and this says negative, and this says negative, and this says negative. Well, something I want you to realize is we taught you anything above an 8, think of like an 80 or above as a test grade. That's strong, okay? So knowing that, if it's above 80, this is actually strong. This is the only one that says positive though. So we're gonna write in strong positive. And then if I rounded this, 6 makes the 6 go up, so it's 0.87, which is here. Okay, last but not least, I'm going to show you this 2 different ways. It says which function best models this graph below, above, whatever, wherever it is. Okay, when we're doing exponential, I want you to remember your starting number is your starting point. Your starting point is your y-intercept. Well, my y-intercept's 50, therefore this is my answer. But let's check our work, because if we're given equations, y'all, let's make sure we're right. So I'm going to type in A, which is g of x equals 50 parentheses 0.8 to the x power. Okay, I'm gonna click the house, and we're gonna make sure this looks the same, and it does. It touches at 50. We can even check a point. If I type the point 1 comma 40, it's on the line. If I type the point 2 comma 32, it's also on the line, so this is the correct answer. All right, y'all, have a great night. Study.